Morning, everyone. We are Scale-Up Localization, a team consisting of one project manager, Eunji, and three Korean linguists, Juyeon, Jane, and Kyung. Today, we are glad to present the result of custom engine pilot project as seen on the screen, which showcases the potential benefits of neural machine translation for official use. Our potential client in this project is the Blue House Secretary from the administration of South Korean President Yoon Suk-yeol. Now I'd like to begin a presentation about our project by briefing our project overview and objectives of the project. Our group has trained the neural machine translation to check if they can be used even in the actual field, which needs a higher level of translation work. To determine the feasibility, we trained the machine translation with speeches of both former and current Korean presidents, achieved the training result, and analyzed them. In this pilot project, we considered three criteria of the determination: efficiency, cost, and quality. Our original objective, which were set out in the beginning, are to translate 30% faster than human translation as an efficiency goal, to set translation rates 40% lower than human translators as a cost goal, and to get faithful, intuitive, and suitable enough to upload the translation onto the government website. The actual outcomes of our project will be discussed later by Kyung. It will approximately 1 month to complete, and our key deliverables would be data sets, summary of training rounds, summary of a human evaluation, budget report, and our suggestions. Now let's take a look at data sets first with Eunji.
Thank you, Juyeon. To recommend a suitable engine for this type of translation to our client, we custom trained 2 MT engines and compare the translation result. One is Microsoft Custom Translator, and another one is a Systran Model Studio. For training, tuning, and testing data for both engines, we use the 2 types of data sets. One is a few open source corpora, which contain about 12,000 segments. Another one is a bilingual speeches of key government officers from former and current administration offices. For example, we use the former president's speeches fitting for training and tuning data sets. For the testing data set, we were able to secure only a handful of bilingual speeches, which is 12 speeches of President Yoon, and we manually aligned them extensively with Trados and made 556 segments. I want to emphasize that we kept our data testing data untouched throughout the entire training rounds, because if the testing data set is somehow modified, it will invalidate the previous round result. Now let me go over the training rounds. So what we did was we ran the first round of the training in both Microsoft and Systran MT engines and performed the human evaluation based on the quality metrics, and also compared the 2 MT engines by reviewing their BLEU score. Then we conducted the second round of the training and compared the 2 MT engines again. After that, we decided to go with the Systran to complete the rest of the 6 rounds of the training due to its higher quality of a translation result. So if you see the BLEU scores of the 2 engines for round 1 and 2 in this slide, there's not much difference, but the translation quality that the 2 engines generated show a big difference. That will be discussed in more detail by Jane later. To keep improving a BLEU score, basically 2 changes were made in the datasets: either adding new or realigned TUs or removing poor quality TUs. In this slide, I will explain what kind of actions contributed to positive and negative result in MT engine training. Positive results were generated when we added new well-aligned TUs in the training data sets, especially when the newly added segments were only speech types. It helped increase BLEU score. Also, deleting lengthy TUs for both source and target text helped. Splitting the source sentences by semantic units also helped. However, when we added less relevant chunks of corpus and the poor quality of the data sets, for example, which the cleanup of the data set was not thoroughly performed, contributed to dropping the BLEU score down. Now let me pass it over to Jane, who is going to explain the human evaluation parts.
Thank you, Inji. For the human evaluation, we conducted a two-part human evaluation. For the first part, we followed the multi-dimensional quality metrics MQM framework to assess the quality of the MT engine generated translations. We took a sample of 1,400 characters from source text and used the same sample for each round of human evaluation. Figure 3 details the different types of errors and the penalty points assigned to each type of error, depending on the severity. Our criteria for a viable PEMT generated translation is that all minor, major, and critical errors combined must not exceed 30 points per 1,400 characters, and there must be no critical error. After the first and 8th or final rounds, our linguists post-edited the MT engine generated translation. Inaccurately translated text was marked in green, while translated text properly corrected from the previous round was marked in red. The second part of the human translation entailed tallying the total penalty points. The results of our human evaluation are as follows. Microsoft Custom Translator produced 41 error points, while the Systran model Studio Lite produced 14 for the first round. In the first round, Microsoft Translator didn't pass our threshold to be a viable engine. On the other hand, Systran consistently showed significantly lower error points. In the final round, Systran only produced 3 error points, which indicates that it is a superior MT engine. This slide shows one of the most important findings of our pilot project. It took our linguists around 2 hours to translate a 1,400 Korean character text into English. Post-editing of the Systran translations took approximately 15 minutes for each round, while post-editing of the Microsoft Custom Translation took 30 minutes. This means that approximately 1.5 hours to 1.75 hours can be saved if an MT engine is used instead of relying completely on human labor. Taking into account the 1.75 hours that were saved, we found that post-editing Systran MT engine generated text was around 8 times faster than relying on human translation alone. Now, let me hand it over to Chuyeon, who is going to explain the project cost breakdown.
Thank you for sharing, Jane. Now I'd like to talk about the cost. The bottom line is that the estimation of actual cost almost doubled, as you can see the table on the screen. That's because the project took nearly twice to complete we thought it would. For most of the tasks from the beginning to end, such as data collection, cleanup, alignment, MT training, and project management, we spent double the anticipated hours. In particular, we spent 50 hours only on the alignment task to fix and realign the poorly prepared dataset to feed into testing and tuning. For human evaluation hours, we spent way less than the hours that we planned. That was the only task which the estimated hours were reduced. We initially estimated the cost would be $3,300, but in the end, the total cost was $5,500. Now, Kyung will going to speak about the original goals of this pilot project and result we obtained.
Thank you, Jian. Initially, our goal was to train a machine so that it could produce a translation at a faster speed, but with a lower cost. We were successful. The machine we trained was 87.5 faster than human translation, while 70% cheaper. Now, of course, we established the quality threshold which we were able to achieve. When we used MQM criteria for post-editing, as Jay mentioned earlier, only 3 minor errors were detected. Considering how significantly fast and cheap the translations are produced, this was a very acceptable quality. Even further so, we can say with confidence that this custom-trained MT engine produces a faithful and intuitive outcomes to allow human translator to only focus on post-editing the machine-produced, MT-produced translations, which are suited for publication onto the official Korean government website in terms of quality, register, and tone. Now that we have completed the pilot project, some recommendations we would like to suggest are the following. Use Systran Model Studio instead of Microsoft's custom translator for its higher quality, lower error count, and user friendliness. For file preparation, use STL Trados to clean and align the data. However, overly lengthy TU segments may cause alignment errors, so caution is advised. For project management, keep data concentrated outside of the MT engine environment using a method such as Google Drive. Plan meetings ahead of time and study the relevant information material beforehand to save everyone's valuable time and sync them correctly. And finally, for some others, maintain the file names organized and concise, since excessively long file names prevent the machine from recognizing the file properly. Thank you for tuning into our presentation. This will now conclude our presentation.